Welcome to UGC's ePathshala lecture series on computer science. The subject is on Introduction to Visualization and the paper is Visualization Techniques. Module 37, it is about document visualization. Some of the learning objectives of this module are: we try to introduce the concept of document visualization. You will also come to know the different types of document visualization techniques, and you will learn the various text corpus and single document visualization techniques, and we will also come to know about the pipeline of document visualization as such. So, let us start with information visualization. A set of technologies has already been developed with the aim of visualizing the information. A large and complex set of information can be assimilated and navigated more easily. These presentation techniques tries to improve both the abstract and the graphical display and real-world grounded interface. So thereby visualizing the text within a document and collection of documents which are likely related comes under this kind of information visualization. There is a difficulty in analysis of these kind of text visualization, which includes the loose structure of the text, the varied vocabulary that is associated with the language of the text, the optional metadata such as the author, date, modification date, comments, keywords, and the catalog codes, citations, etc. are certain attributes that are associated with the text, and there are difficulty in analyzing those kind of metadata that are associated with the text as such. So, if you look at the levels of text that are supposed to be represented or shown in a graphical manner, we can actually look at the levels of text as three different levels. First one is the lexical level, which actually comprises of simple grouping of characters like tokens, which are basically the words and which represents the word stems, phrases or n-grams and character n-grams, which may be beneficial. Basically, the word stems or the root words. So, for example, jumping, if you take jumping as a word, then in that case jump is a root word, or the words ing is a word stem that is associated with the word root word jump. So, similarly, you have something called as word n-gram, wherein n represents the number of words that we try to concentrate. So, blackboard is a bigram word where you have two words associated with a single word. So, similarly, you can have character n-grams also. The next level of looking at the text is the syntactic level, where you try to parse for a purpose of a particular token, the grammatical category, the tense, the plurality or the context in the case of the phrase, sentence and paragraph. So, in syntactic level of approach of the text, we try to look at the grammatical information associated with the text as such. So, the various natural language text as such are considered, and we look at the parts of speech or the plural or the gender or the tense associated with each and every phrase, sentence and paragraph of the particular text. That is a syntactic level approach. The third level of approach of the text is a semantic level approach, where we try to extract the meaning of the syntactic structure with respect to the tokens using the fuller analysis of the context as such. So, the meaningful information that is present inside the text is actually considered in the case of the semantic level approach of the text. So, these are various levels of text that are supposed to be represented in the graphical format in a document visualization. So, usually text uses a vector space model of representation, wherein the analysis of the words in the document determine the value in contribution and significance to the document. So, first we try to remove some of the noise words which are, for example, like a, and, the, that, punctuation, and stemming, where we try to collect the root words. These are some kind of typical pre-processing tasks. After removing all these things, so which are actually called as the pre-processing steps are like stemming and noise word removal. Later on, we try to count the simple frequency count of significant words which are ordered by the decreasing frequency of a particular term in a simple way and is represented in the form of a simple vector. So if you look at this about text, this can be represented in the vector format like this, wherein level is a word which has got a frequency of 4, word is a word which has got a frequency of 3, token is a word which has got a frequency of 3, syntactic 2, and similarly so on, where this is called as a vector space model of representation of the given text. So there are various ways of representing the document as such. Trees are the most popular way of representing the documents. So hierarchically organized data structures or trees are the most widely visualized systems for cluster of documents. Some common techniques which are used for visualizing trees are hyperbolic tree, tree maps, and cone trees, although there are other types of trees that are available. Hyperbolic tree is also called as a topic map, as it provides a means of navigating the topics in high-wire journals using a Java applet. So these are some examples of document visualization techniques wherein the set of documents are represented in the form of tree maps. So similar related documents are being clustered and they are put in the form of rectangles, and they are represented in the form of nested rectangles in the form of a tree map. So this is a hyperbolic tree which is shown on the highwire.org, and this is a tree map which is a screenshot that is taken on labscape.com. Then these are other representation visualization techniques that are applied for the documents. The tree map has a recent application in business intelligence and analytical CRM applications and are also used to visualize the search result, while a commercial product of cone trees named as the LexiQuest Mine is used by a number of large corporations. So here this is an example of a cone tree. This is an example of a disk tree where the nodes are represented in the form of a disks here and the nodes are represented in the form of cones here. So this is a compact disk tree and this is a plain disk tree as such. So you have the root node in the center of the tree and you have all the child nodes surrounding the tree as such. So here each and every child node represents one set of, one particular document, and the root node represents another document. This shows a relationship between various documents, and this is a visualization of collection of documents as such. So if we look at document visualization in the form of trees, there are recent research that has been developed in the variation of the cone tree, which are also called as the reconfigurable disk tree or the RDT, which tries to flatten each cone and also gives the sense of less clutter. So these kind of RDTs tries to combine the idea of tree map and cone tree as such in an attempt to elevate this. The disadvantages of cone tree is visualizing large hierarchies while maintaining its context using the 3D depth information. A general comparison are also given in this table where we try to compare the tree map, cone tree, and the reconfigurable disk trees. Tree maps are going to be 2D trees and are going to be simple in nature. Cone trees are 3D trees, and RD trees can be 2D or 3D trees. In the case of tree map, you have a visual clutter for large hierarchies, whereas the visual clutter for hierarchies greater than 10,000 nodes are seen in the case of cone trees, whereas RD trees can handle more nodes than cone trees. Cone trees cannot avoid overlaps when projected to 2D, and RD trees can handle overlap for 2D projection. So for visualization of a simple document collection, some techniques attempt to map the collection into a multivariate space as such. The problem of document visualization then in this case becomes a problem of how to locate a document in a predefined information space as such. There are various other document visualization techniques which are used to show the search result. For instance, the NIST has developed a set of solutions to investigate the visualization of the search result, in which the document spiral emphasizes the relevance ranking assigned to the documents by the search engine. The 3 keyword axis display emphasizes the frequency of the particular query terms in the documents, and also the nearest neighbor clustering is used to show how the documents are related to each other based on the query term frequency. So this is a very good example of a search result document visualization. So here you can see the document spiral, the 3 keyword arcs are being shown here, and the nearest neighbor clustering approach is shown on the right hand side. So there is another one example which is called as a fractal room, which is a technique used to display the result set of queries for multidimensional data set as such. As shown in the illustration, you can see that a single search result will be displayed as a virtual object inside a room where all the information about the results is shown using pictures and sound. So this is an visualization of a fractal room. So here this particular visualization is very helpful for visualizing some kind of ordered multimedia data. So this kind of technology is useful to display a set of multimedia data which are ordered according to some particular kind of indexing. So if you look at each and every object, that represents each and every document as such. So you have various rooms which are represented in the form of a virtual fractal room. There are various kinds of interaction approaches that can be applied over these kind of document visualization techniques. So alongside the various visualization method, a group of technologies exists that can further improve the presentation and engender the effect of HCI. Examples of these kind of technologies are bifocal, fisheye, perspective wall, and rapid serial visual processing. These kind of technologies use the multimedia interactions to reproduce and reorganize the information according to the user's current interest and preferences. Additionally, some other new techniques like elliptical view and inverted triangle view also place the documents at absolute positions within a large zoomable space. When combined with animated navigation, this gives the user a sense of structure and of where they are within the space of documents. Also, these kind of zooming solve some of the problems of limited display size. Some of the document visualization techniques also tries to visualize the HTML documents. The content tree, which is based on the HTML transformation, provides another way of representing the logical structure of the HTML document. This is also used to provide several views that are suitable for display on a wealth of small displays. So Car2 is a tool which uses a few search engines and also delivers a visualization of the search result to the end users. Car2 produces an image representation of the results with the balls representing the different web pages and the link between the balls which indicate the keywords that tries to link the web pages. The size of each ball here enables the user to determine the relevance of each of the sites to the search items, and larger the size, greater the match to the search criteria. This initial presentation of the result was overly complicated and they attempted to include too much detail, thus reducing the effectiveness of the search engine as a whole. So now Cartoon has since then been updated in order to improve the usability and make it slightly easier to interpret the content of visual representation. The main and the most obvious modification that has been given to Car2 was on the layout, so far as the interactive map that has been produced as a cleaner and better ordered layout as such. Links between sites are only visible while the pointer is over a site, and the sites are now represented by icon indicating the content type. A possible improvement to visualization of web search result would be to couple within document visualization with between document visualization, which will talk about the interrelationship that exists between the documents. So within document visualization represents a summary of a large document to aid rapid navigation to sections of interest, and between document showing the interrelationship between a very large set of documents. The advantages of these kind of multi-level document visualization include the ability for the user to obtain an overview of the text that is directly tied to a normal reading view. In the general case, this may be extended to any number of views at different levels of granularity, and as long as the relationship between the views is clearly being shown. Such views also allow the combination of the tools to provide novel opportunities for using electronic text, limiting the potential by the imagination of users and developers. The script analysis for double casting, thematic studies of literacy classics, adoption of newspaper articles for acquiring skills are few ideas that can be used for such kind of visualization. Document visualization also tries to visualize the references that are given at the end for any kind of document. So they can be found and they can be applied in many contexts. One such example is a RefVis, which is a product that tries to organize the references to help a user's decision process when selecting the references relevant to a particular interest. Future research also needs to include more HCI study and user needs and practice elicitation via observation and co-participatory design. So if you look at the text document or document as a whole, which is called as a corpus visualization, automated text processing is commonly used when dealing with text data which is written in a natural language. However, when processing the data using computers, we should be aware of the fact that many words having different form share a common or a similar meaning. So for a particular computer, this may be difficult to handle without some additional information, that is a background knowledge. So a technique by name latent semantic indexing is used for extracting this kind of background knowledge from the text to documents. Later, it uses a technique from linear algebra called SVD, or the singular value decomposition technique, on the bag of words representation of text documents for extracting words with similar meanings. So this can also be viewed as an extraction of hidden semantic concepts from the text documents. So visualization of the document corpus is very helpful for finding the main topics that the documents from this corpus talks about. For example, given a set of descriptions of European research projects in IT, using document visualization, one can also find the main areas that these projects cover, such as a semantic web, e-learning, security, etc. And the bag of word representation has got very high dimensionality. In order to visually represent the text documents, the number of dimensions has to be reduced as such. This can be done by first extracting the main concepts using LSI, and then using this information to position the documents onto a two-dimensional plane that can be plotted on a computer screen. So this is an example visualization of the European IST projects from the 6th framework. Here we can see the set of documents that are being represented. So the entire set of documents are represented by extracting the topic information related to each and every document, looking at the interrelationship between each and every document, and we also try to reduce the dimension of each and every document using the LSI SBD approach as such. So this is another screenshot of the same visualization. This is a visualization of questions from Spanish judges, which is shown as similar to the previous slide. So if you look at these kind of sequential document visualization, documents and other categorical value time series are often characterized by frequencies of short range sequential patterns, which are also called as n-grams. This representation converts the sequential data of varying lengths to high dimensional histogram vectors, which can be modeled by standard statistical models. Unfortunately, these kind of histogram representation ignores most of the medium and long range sequential dependencies that exist and make it unsuitable for visualizing the sequential data. A novel framework is being used for sequential visualization of discrete categorical time series based on the idea of local statistical modeling. And this framework embeds categorical time series as smooth curves in the multinomial simplex summarization, which is a progression of sequential trends. So as such, if you see, this is a sequential document visualization. So here you have the time axis as well as a velocity axis, and here this represents the terms that are present in each and every document which is being represented in the timeline as such. This is called as a sequential document visualization tool. We also try to map the vector space model to the document. So here you can see that this example highlights the named entities. Persons' names are shown as red colors, place names are shown as green colors, and the date are represented in cyan color and so. So this shows a vector space model representation of the document. So for single document visualization, we can also go in for cloud tag, crowd tags, and we can also visualize the words by the size based on the frequency. This is a single document visualization. Here, looking at this particular visualization, we can say that analysis is a term which has appeared in this document more number of times. Level is a term which has appeared in this document more number of times, and tokens is a term which has appeared in this document for more number of times, whereas catalog, category, corpus are terms which appear very less number of times in this particular document. This is a single document visualization. Wordle is a tool. So here below is a visualization by this Wordle tool with size represents the frequency of that particular word. So level is a word where we can see the size of the word level is more, which means that level is a word which has occurred more number of times in this particular document. Whereas within is a word which has occurred less number of times because the size of within is very less when compared to that of other terms present in that particular document. So Wordle is a tool which tries to visualize a single document in this way. Then we have some other layouts like language and color options which are available in Wordle as such. So Wordle also has language options wherein you can change the language options. You can also use a color pane to represent various terms using various different colors as such. Then you have something called as a word tree which is available through the IBM Mini Eyes. Here we try to enter a word and then we can interactively choose the next words. So this is, you can also customize the word tree. The data set for this is a sample text stream and the visualization will be as follows. So the context of the phrase sentence semantic level. So here you can see it is the document is represented in the form of a tree with respect to the frequency order. So the occurs more number of times, context text loose occurs more number of times in the given document. So this is represented in the form of a word tree as such. So till now we have been looking at various visualization which tries to visualize only a single document. Next we are going to look at various visualization techniques which tries to show the entire document collection as such. So the goal here is to place similar documents close to each other. So there are various approaches to show that. Some of the approaches are graph spring layouts, multidimensional scaling approaches, clustering approaches, self-organizing maps. Self-organizing maps use the vectors from each document to calculate the distance from each other. Higher weights try to draw the documents close to each other and randomly start, and here in this case we try to randomly start with one single document. The document cards represents a document's semantics as a mixture of images and key terms. This works for academic documents where the metadata is also available. So finally, if we look at the pipeline of document visualization, you can see that you have the text you try in the form of PDF or some other document file. You try to extract the full text from the entire document as such. The full text is being extracted. Similarly, the image is also being extracted. Then the image is being filtered. The key terms are being extracted from the full text. Along with the image, we try to pack the key term as well as the image. We try to place the term in particular location and then we try to display it in a particular format. So this is a general pipeline of a document visualization. So here if you see, you have the PDF wherein you try to extract the text as well as the image. You try to perform image filtering. You try to extract the key terms from the given text. You try to merge the image with respect to the text and then show it in the form of a display. So here is a display which shows the image as well as the text in a visualized format. So the interaction in this case are caption. You can have a caption tooltip. You can have an abstract tooltip. You can move to the original position. There are something called as page switches and you can also use term highlighting. So these are various interactions that can be carried out over the display that is being shown here. So the fetching process, if you look at the fetching process, you have the corpus of corpora, which means a corpus, as I said, represents a set of document collections. So you have the corpus, you have the document cluster as such. You try to extract from the document cluster, you try to extract the document. From a single document, you try to extract the chapter, each and every chapter of the document. Then you try to extract each and every section of a single chapter, extract the paragraph from every section, extract the sentence, try to extract the word group, try to extract the word and try to extract the letter. So this is basically done in a time-bound basis. So here this is a top wherein you try to give the set of documents or the corpora as such. So this entire process is called as a fetching process where you try to fetch the letter, a single letter from a corpus of text as such. So this also represents the hierarchy of the documents where the highest node represents the set of document collections and the lowest node or the leaf represent a single letter that is present in the entire document collection. So, this is also called as a fetching process. So, if you want to compare the topics between various text collection, this is a kind of visual which tries to show the comparison between various, comparison of topics between various text collections. So, here you have the comparison of 495 papers of information visualization, science visualization and SIGGRAPH, SIGGRAPH visualization conferences that are being held at various locations. The discrimination threshold is 6 and the number of topics that are being extracted is about 30. So, here they have shown this is a focus plus context approach, wherein in the focused approach you can see the one particular information that is being extracted. So, here you can have a look at the various topics that are being represented using one particular circle and the relationship between various circles, and similar documents are placed near each other. Here the color code also represents the 3 different conferences. The orange color, blue color and the green color represents 3 different conferences. So, in all the 3 different conferences, similar papers are being extracted. The keywords are also extracted from the similar papers and they are being visualized in this particular manner. So, there is another approach which is called as text translation approach. Some kind of text translation can also be visualized in a particular manner. So, if you look at the translation lattice for the German sentence hello, which follows with some kind of German words, statistically we try to identify the best path along the bottom, and if it is an incorrect path we try to repair it. Photo notes also provide an alternative representation of words not in the translation vocabulary, and mouse over tries to expand the node and reveals the 4 photos which other nodes move away, so that they try to avoid the occlusion or the hiding the essential part of it. So, here if you see there is a path that exists which shows the translation of the text translation of the given sentence. So, here if you move along this path which has been highlighted, then that gives the translation of the given sentence that has been looked earlier. So, if you want to summarize, we can notice that in the case of document visualization, we have been talking about what documents are, what clusters of documents are all about, and we also looked at the different representation techniques that are useful to represent the entire document as such. For example, the vector space model, the bag of words model, etc. And then we looked at different types of document visualization techniques. For example, like search result visualization, or named entity visualization, or frequency of word visualization that appears inside a single document or within a set of documents as such. We have also looked at various single document visualization techniques and a set of document which is called as corpus visualization technique. And finally, we have looked at the pipeline of document visualization, wherein given the entire one document or set of documents, it is possible for us to extract the text on the image from the given document, filter them, place them in a proper way and show it in the form of a visual to the end user. So, thank you.